Welcome to absolute value equations. The goals of this video are to solve absolute value equations algebraically and solve them graphically. Let's start off by reviewing the definition of absolute value. A number's absolute value is its distance from zero on the number line, and as we know, a distance is always going to be positive. So for example, the absolute value of positive 3 is equal to 3 since this number is 3 units from 0. Well, the absolute value of negative 3 is also equal to 3 because negative 3 is also 3 units from 0. So when we transition to an absolute value equation, we can think of what numbers have an absolute value that is equal to positive 2, or what numbers on the number line are 2 units from 0. And we should be able to notice now that there are going to be two solutions to this equation because positive 2 is 2 units from 0, and so is negative 2. So the solution to this equation would be x equals positive 2 and x equals negative 2. So let's talk about the absolute value principle for equations. For any positive number c in any algebraic expression x, the solutions of the absolute value of x equal to c, a positive value, are those numbers that satisfy the equation x equals negative c or x equals positive c. Now remember, we're using x here, but this could be any expression involving x. There are two other cases. If we have the absolute value of x equal to 0, this is equivalent to the equation x equals 0 because we know positive 0 and negative 0 results in 0. And the last case is when we have the absolute value of x equal to negative c, and this has no solution because we should know now that the absolute value means a distance, and distance can never be 0. So here are the steps we're going to take to solve absolute value equations. Step 1, we must isolate the absolute value. Step 2, we will set up and solve two equations based upon the absolute value principle, where we have the absolute value of x equal to a positive c. So we'll take the expression inside the absolute value symbol, set it equal to negative c and positive c, and solve. And then lastly, we'll check our answers. Let's go ahead and give it a try. The absolute value of x is equal to 6. Our absolute value is already isolated, so our two equations will be x is equal to positive 6 and x is equal to negative 6. And just to check this, the absolute value of 6 is positive 6, and the absolute value of negative 6 is equal to positive 6. That checks. Okay, right away on number 2, they're testing us. We have the absolute value of x plus 1 is equal to negative 2. Well, we know an absolute value can never equal a negative number. Therefore, this equation will have no solution. However, if you don't recognize that right away and you do try to set up your two equations as x plus 1 equals negative 2 and x plus 1 equal to positive 2, we can still solve these. Subtract 1 on both sides. Again, subtract 1. Now we may think these would be solutions, but if we actually go back and check them, using x equals negative 3, we'd have the absolute value of negative 2 is equal to negative 2, which is false. And then when x is equal to 1, again it's false because we know it can never be negative. So if we recognize this from the very beginning that we're going to have no solution, we can stop and move on to the next problem. If you don't recognize that and solve, we've just illustrated why it's important that you do have to check your work. Let's look at a couple more and then we'll take a look at how we can solve these graphically. So it is important that we isolate the absolute value first. So on this problem we'll add 3 to both sides. That would result in the absolute value of 2x plus 3 is equal to positive 9. This is the form of the equation that we use to set up and solve our two equations. If we try to use it in this form and use a positive 6 and a negative 6, we will not get the correct answers. And that's a very common error that I see. So our first equation will be 2x plus 3 can equal 9, and 2x plus 3 can also equal negative 9. And hopefully this makes sense as to why we're setting these two equations up. It comes from the fact that the absolute value of 9 is equal to 9, and so is the absolute value of negative 9. So this 9 is really this 9 here, and this negative 9 is really this negative 9 here. Let's go ahead and solve this. Subtract 3 on both sides, divide by 2. Same procedures here, but now when we subtract 3 on both sides, we'll have a negative 12 on the right. divide by 2, x equals negative 6. So our solutions are x equals 3 and x equals negative 6. You can see as soon as you set up your two equations, it's pretty straightforward. It's just making sure you follow the correct techniques to set up these two linear equations. Number 4, here is the absolute value piece that we must isolate. So first we'll subtract 4 on both sides. 12 minus 4 would give us 8. This is connected by multiplication, so we'll divide both sides by a positive 2. So we have the absolute value of 4x minus 2 is equal to positive 4. You will have two linear equations to solve. The first one will be 4x minus 2 is equal to positive 4, or 4x minus 2 could equal negative 4. So here we'll add 2 to both sides. 4x equals 6, divide by 4, x equals 3 halves. Same steps, add 2 to both sides. Negative 4 plus 2 would be negative 2. Again, divide by positive 4. We have x equal to negative 1/2. As expected, we have two solutions. So you can see the pattern here. We can expect two solutions to most absolute value equations unless the absolute value is equal to a negative number where we have no solutions, or where it's equal to 0 and we would have one solution. So let's take a look at how we can solve absolute value equations graphically. Step 1, graph the left side of the equation in y1, graph the right side of the equation in y2, determine the points of intersection, and the x-coordinates of the points of intersection are the solutions. Let's go ahead and give it a try. So we're going to graph the absolute value of 2x plus 1 in y1, and we'll graph 5 in y2. Press y equals. If you have any old equations in there, clear those out. To access the absolute value, press Math, right arrow once. ABS stands for absolute value. Press Enter. Type in x plus 2. Type in x plus 2. Close the parenthesis. There's y1. y2 is equal to 5. To make sure we have the standard window, let's hit zoom 6. We'll see 2 points of intersection. These x-coordinates of these points represent the solutions. If we press second trace, option 5, the calculator can only find one point of intersection at a time. We want to move the cursor close to the point of intersection we want to find first. Let's find the one on the right first. Press Enter 3 times, and we can see one solution is x equals 3. Let's record this. Now we'll go back and find the second solution. Press second trace, option 5. Now move the cursor close to the left point of intersection. Press Enter 3 times, and we have x equals negative 7. That was pretty quick and painless, but let's go ahead and check our work. First, x is equal to 3, which satisfies the equation. Next, x is negative 7, and the absolute value of negative 5 is 5, so both solutions check. Let's try one more. Now in this one, again, we do not have to isolate the absolute value if we're solving graphically. This will be y1, and this will be y2. Remember, to access the absolute value, we hit Math, right arrow once, and then Enter. Close the set of parentheses. There's y1. y2 will be 11. Now this will be an issue because remember the standard window only goes up to 10, so we'll have to change our y maximum. Notice if we press Graph, we do not see the horizontal line. So if we press Window and change our y maximum so that it includes 11, I'll change it to 15, and now press Graph. We now can see the points of intersection. So again, press second trace, option 5. I'll find the negative solution first, Enter 3 times, x equals negative 2, and the second solution, x equals 3. I hope you found this video helpful.